Right, we've been talking about inequations, but all the equations we've been doing pretty much been in, well, one dimension. We've been using one variable, x is greater than or less than and so on. Of course, we can bring that out to two dimensions, having two variables by using a number plane and looking at regions in the plane. So to do our regions, obviously the first thing we've got to do is sketch the curve itself, because that will be the boundary, much like on the number line we use the dots to represent the boundary. If it's just less than or greater than, remember we just dot the boundary to indicate not included. If it is included, then we draw a solid line to say the boundary, yes, that is included. Now, if the point of intersection is not included, then just like we did on the number line, we would have a hollow circle at that point. And because it's a point of intersection, both have to be included for the point to be included. So if just one of those boundaries is a less than or a greater than, then the point of intersection is not included. And then just like we did on the number line, we just test points to see, okay, which section are we in? So let's just start with the basic straight line. So y is less than x plus 3. So we'll dot in x plus 3. That splits our number plane into two sections. Again, we want to make life easy for ourselves, so I'm always going to pick the point 0, 0, or the origin, unless the boundary happens to go through that, then it's going to be easy. So here we go, test 0, 0, sub it in, we get 0. Yes, that is less than 3, so there's our region, the right-hand side of it. Okay. Circle. This time the boundary is included, so we'll include our circle. There it is. Once again, we've split the number plane up into two sections, inside the circle, outside the circle. 0, 0 is inside, so another easy one to use. Is 0 greater than or equal to 9? No. So we must be outside the circle. Semicircles are interesting. Y is less than the square root of 4 minus x squared. So it's just dotted, and we get our semicircle, and it looks like we haven't really broken it into two regions because it sort of spills over. There's no boundary here. Well, let's just test the point 0, 0 to see if it is included. And yeah, 0 is less than 2, so we are included. So all right, we're inside the semicircle, but as I say, the x-axis is not a boundary. So we don't actually stop there. What we have to do with something like this is to take into account the domain of the actual shape itself. The domain for a semicircle, or this semicircle, is minus 2 to 2. And look, we're saying when is y less than? So whenever I have a number underneath the x-axis, that y value has got to be less than the positive square root. So as long as it's in the domain, it should be included. You'll also notice the boundary, whilst the semicircle itself is dotted, the boundary of the section underneath is not, it's solid. If you pick any point, again, sub it in, it will satisfy it, because the y value is negative. So it's going to be less than the square root. The point of intersection, however, because one of them is dotted and one is solid, we should circle the point of intersection, because that won't be true if you substitute in. I mean, let's substitute the point 2, 0 in. We'll get 0 is less than the square root of 4 minus 2 squared. Well, 4 minus 2 squared is 0, and 0 is not less than 0, so it's not included. So the point of intersection we would circle. If it was a greater one, then again we'd have the domain, but you'd see that corridor, if you could, for want of a better word, that corridor would be above the semicircle rather than below the semicircle. So watch out for things like square roots. You might have to pay attention to the domain for the region that we're in. Okay, we could have a combination of more than one function. So y is greater than or equal to x squared, and also less than or equal to 3x plus 4. So let's do them one by one. I'll do the parabola first, solid line, because it's equal to. And, I mean, it keeps going to infinity, so either we're inside the parabola or we're outside the parabola. Can't use 0, 0 this time, because the boundary's on it. So I've got to pick a point that I know is definitely either inside or outside. So any value on one of the axes, which one did I use? I went for 0, 1. I know that's definitely inside the parabola. So let's test it. 0 less than or equal to 1, yes, it is. So I know I'm inside, but I'm not going to shade the complete inside yet. I'm just going to make some marks so I know, righto, I'm on that side of the parabola. So some crosses or whatever. Now let's do the line. So there's y equals 3x plus 4. It's also included. Yeah, it's probably handy to find the points of intersection for the sake of completeness. Plus also it gives scale to the line, so we know exactly where it is. So solve them simultaneously. We end up with -1 and 4. So all right, the first point on the left there is -1, 1, and the one on the right is 4, 16. Now which side of the line are we on? Let's pick a point. Well, this time I can use the origin. And 0 is less than or equal to 4. Yes, of course it is. So I know, and I'll put some red crosses on the right hand side. So basically the region I'm looking for is the one that has both red crosses and blue crosses. So I must be in that little section in there. Okay, so 3F, playing with regions and getting the colour in. It's just like geography.